Rigging is the planned movement of material and equipment from one place to another using ropes, chains, hoists, or other types of equipment. To safely accomplish any rigging operation, you have to be able to select the proper equipment to use for the job, determine if the equipment is in acceptable condition, and properly carry out the procedures involved in rigging and moving the load. Rigging jobs can vary from routine lifting maneuvers to complex and specialized operations. But regardless of the job, some of the basic components are likely to be the same. In general, synthetic fiber ropes are stronger and more resistant to stretching than natural fiber ropes. Also, some synthetic fiber ropes are more resistant to chemicals and abrasion than natural fiber ropes. However, synthetic fiber ropes are susceptible to damage caused by long exposure to sunlight. For that reason, they should be stored in a cool, dark place. Like wire rope, chain can be used in many different rigging operations. But chain weighs much more than wire rope of the same capacity, and it has less ability to stretch, which sometimes causes it to snap without warning. However, these disadvantages are balanced by chain's ability to turn tight corners without suffering undue wear or damage. One type of chain that's used in rigging is common chain. It's constructed of interlocked welded links of forged steel. In general, the capacity of the chain is determined by the thickness of the metal from which the links are made. Most rigging operations require some basic hardware to link separate pieces of equipment. For example, wire rope has limited flexibility, and it should never be tied in a knot. So various types of end fittings and connectors are needed to attach it to other sections of rope or chain or to a load. With a wedge socket, the end of the wire rope is passed through the socket, looped, and then reinserted into the socket. A wedge is positioned inside the loop to prevent the wire rope from pulling out of the socket. The dead end of the rope is secured by clamping a separate piece of wire rope to it. Like an open socket, a wedge socket has a removable pin that can be used to attach the socket to other equipment. During a rigging operation, the load that's being moved must be connected to the device that's doing the lifting. Often, the connecting link between the lifting device and the load itself is a length of wire rope, chain, or synthetic material called a sling. Like any equipment, the equipment used in rigging is subject to wear and damage. This wear and damage can seriously affect the capacity of the equipment and lead to accidents that could cause injuries and destruction of property. To prevent these problems, rigging equipment should be inspected before it's used to ensure that it's in good condition. Equipment inspections are a vital part of rigging safety. All rigging equipment should be inspected before each use, and if the equipment is used for an extended period of time, it should be inspected on a regular basis. Government agencies as well as private industries have rules regarding equipment inspections and allowable limits of wear and damage. Let's look at what's involved in some of these inspections now. The thing to remember about a wire rope inspection is that any significant wear or damage can affect the strength of the rope and make it unsafe. Also, since wire rope is susceptible to damage such as broken wires, you should always wear gloves when you're working with it to prevent cuts and scratches on your hands. Most of the damage to a connector or fitting can be detected through a visual inspection, but some defects, such as hairline cracks caused by overloading, aren't easy to see. To check for these types of problems, other methods, such as liquid penetrant testing, are sometimes used. These types of tests use liquids that are able to seep into tiny defects in the surface of a component to make them visible. In addition to inspecting the equipment that's used in a rigging operation, it's also important to check the load that's being moved. For example, a load or piece of equipment should be checked to make sure that there are no loose parts that could fall off when the load is lifted, and no damaged or defective lifting lugs or pad eyes. If the load has eye bolts for rigging, they must be screwed in all the way. Also, keep in mind that the way the load is rigged depends on the type of eye bolts that are used. Shoulder-type eye bolts, which have a widened area just below the eye, are suitable for angular lifts. Straight or shoulderless eye bolts should be used for straight lifts only. One piece of equipment that's sometimes used in rigging is a derrick. A derrick is basically a stationary crane that's used primarily for straight lifting, although some derricks can provide some lateral movement of the load. Cranes are used to lift and move materials and equipment from one place to another. There are a number of different types of cranes available. Some of them are mobile, others remain stationary for the most part. In this part of the program, we'll look at a few of the more common types of cranes used in rigging. Cranes are typically operated in noisy areas, and the crane operator often can't see either the load or the area where the load is supposed to be placed. Sometimes rigging personnel use radios to direct the crane operator, but often a rigger or flagman on the ground uses hand signals. In this part of the program, we'll look at some of the hand signals commonly used for different types of cranes. As we do, keep in mind that even though the signals we'll see are standard, flagmen and crane operators must always agree on them before a lift is attempted. Here's a list of the hand signals that we'll examine. Use the Go button to view the signals in sequence. After each signal plays, you can select Replay if you want to view the signal again. This is the Raise Load signal. It tells the operator to raise the load using only the lifting tackle. The boom should not move. The Raise Load Slowly signal tells the operator to raise the load slowly using only the lifting tackle. This signal is produced by making the Raise Load signal while holding your other hand flat above the signal. The Lower Load signal tells the operator to lower the load using only the lifting tackle. The boom should not move. The Lower Load Slowly signal is produced by making the lower load signal while holding your other hand flat beneath the signal. It tells the operator to lower the load slowly using only the lifting tackle. This is the Raise Boom signal. It tells the operator to raise the crane's boom. The Raise Boom Slowly signal tells the operator to raise the boom slowly. It's produced by making the Raise Boom signal while holding your other hand flat above the signal. Here's the Lower Boom signal. It tells the operator to lower the crane's boom. The Lower Boom Slowly signal tells the operator to lower the boom slowly. This signal is produced by making the Lower Boom signal while holding your other hand flat beneath the signal. The Raise Boom Lower Load signal tells the operator to raise the boom and lower the load at the same time. It's produced by extending your arm, pointing your thumb upward, and opening and closing your fingers repeatedly. The Lower Boom Raise Load signal tells the operator to lower the boom and raise the load at the same time. It's produced by extending your arm, pointing your thumb downward, and opening and closing your fingers repeatedly. The Extend Boom signal is used for cranes with telescoping booms. It tells the operator to extend or push out the boom. The Extend Boom signal can also be given with one hand. To do this, hold one hand against your chest, keeping your fist closed and your thumb pointing upward toward your chest. Another signal that's used for cranes with telescoping booms is the Retract Boom signal. It tells the operator to retract or pull in the boom. The Retract Boom signal can also be given with one hand. To do this, hold one hand against your chest, keeping your fist closed and your thumb pointing away from your chest. The Swing Load signal tells the operator to swing the boom and the load to the left or right. It's produced by extending your arm with your hand open so that your fingers point in the direction that you want the load to swing. The Travel Crane signal tells the operator to move the crane to another position. This signal is typically made by rolling one hand over the other in the direction that you want the crane to move. The Travel Bridge signal tells the operator to move the bridge of a gantry crane in one direction or the other. It's produced by raising an open hand to about shoulder height and making a pushing motion in the direction that you want the bridge to move. The travel trolley signal tells the operator to move the trolley of a tower crane in one direction or the other. This signal is produced by holding one closed hand at about shoulder height with your thumb pointing in the direction that you want the trolley to move. The select trolley signal tells the operator which trolley to use on a tower crane that has more than one trolley. For example, hold up one finger to specify the trolley marked 1 and 2 fingers to specify the trolley marked 2. The stop signal, which is often made by extending your arm and clenching your fist, tells the operator to stop the operation being performed. Sometimes the stop signal is given by extending one arm with your palm down and making a slicing motion. The emergency stop signal is given in emergency situations. It's produced by extending both arms outward with your palms down and making slicing motions with them. The dog everything signal tells the operator to shut down the operation and secure everything in its present state. This signal tells the operator to use the main hoist. It's made by first tapping the top of your head with a closed fist, then using the applicable hand signal. This signal tells the operator to use the whip line or auxiliary hoist. It's made by closing one fist, bending your elbow at a 90-degree angle, tapping your elbow with the other open hand, and then using the applicable hand signal. Part of planning any rigging job is being able to select the proper equipment. To do that, you need to have a good estimation of the size of the load, the weight of the load, and the load's center of gravity. That is, the point at which the load's weight is concentrated. The size of a load is determined by measurements such as length, width, and height. The surest way to find those measurements is to use a rule or tape measure. But sometimes an object is too big or too hard to reach to measure. In those cases, you might have to estimate the object's size. An estimation is not simply a guess, it's a close calculation. One way to estimate an object's size is to compare the object to a measurement that you already know. To help with these comparisons, it's useful to learn the measurements of different parts of your body. Knowing the size of a load can make it easier to determine the weight of the load. You have to know the weight of the load within a certain range so that you don't use the wrong rigging equipment or overload the equipment. Sometimes the size and weight of an object are printed on a data plate or on a packing crate. But if this information isn't available, you'll need to estimate the weight of the object. One way to estimate the weight of an object is to compare it to a similar object with a known weight. If you don't know the weight of a load and there's no chart to help you estimate the weight, contact your supervisor or other appropriate personnel. Never try to lift a load without having at least a close estimation of its weight. For some lightweight rigging jobs where wire rope isn't necessary, fiber rope may be used. Using fiber rope requires that you be able to tie a sturdy, secure knot. In this part, we'll see how to tie several knots that are frequently used in rigging. To tie a bowline, first make a loop near the end of the rope that passes over the long or standing part of the rope. Then pass the short or running end of the rope through the bottom of the loop, around the standing part, and back through the loop. Tighten the knot by pulling the standing part and the running end in opposite directions. One way to tie a running bowline is to make a small loop near the end of the rope and drop the standing part of the rope behind the loop. Then pass the running end of the rope behind the standing part and tie a bowline in the running end. The running bowline forms a running noose or slip knot, which will tighten when the standing part of the rope is pulled. To tie a timber hitch, first loop the running end of the rope around the object to be tied, then pass the running end around the standing part of the rope and back around itself 2 or 3 times. The knot will tighten as the standing part of the rope is pulled. Be sure to keep a steady pull on the rope so that it won't loosen and slip off. Often, a half hitch is used along with the timber hitch. A half hitch is tied by looping the rope around the object, then passing the end underneath the standing part. Using a half hitch together with a timber hitch can provide added stability for long loads. To tie a square knot, first cross the end of one rope over the end of the other and wrap it around the end one time. Then cross the same end back over the other end heading in the opposite direction and wrap it again. Tighten the square knot by pulling the ends of the ropes in opposite directions. To tie a clove hitch, loop the end of the rope around the load and back under the standing part. Then, loop the rope around the load a second time above the first loop and tuck the end of the rope underneath the loop. One way to tie a barrel hitch is to start by tying a figure-8 knot in the rope and opening it wide on the ground, like this. Then place the object being lifted over the center part of the knot and lift both ends of the rope. At the top of the object, tie a bowline knot in the running end of the rope and pass the standing part of the rope through it. This basically forms a running bowline, which tightens like a slip knot when the standing part of the rope is pulled. Safely rigging and moving objects involves carefully planning for the job, selecting the proper equipment for the job, and making sure that the equipment is in good condition, and then using the equipment properly. While the exact procedures used during a rigging job can vary, many of the basic steps are the same. The main consideration during any rigging job is safety. For that reason, rigging personnel should always wear the proper protective clothing and safety gear, including safety glasses, a hard hat, and gloves. Riggers should agree beforehand on any hand signals that will be used during a rigging job. Signalmen must know the standard crane hand signals and be able to give the signals clearly. They must also be able to recognize hazards and signal the operator to avoid them. Equipment operators must be competent and properly trained. In some cases, they must also be licensed to operate mobile cranes. To prepare for rigging and moving a load, riggers should determine the size and weight of the load. They should also determine where the load will be moved to and the route that will be taken. The area around the load and the route that the load will be moved along should be checked for obstructions and to make sure that no personnel will be under the load at any time. The rigger should also clear the area where the load will be placed and put down any supports that are needed for the load to rest on. In addition to the object being moved, the working load includes the crane load blocks, load lines, and all lifting tackle. To ensure that the crane's lifting capacity isn't exceeded, riggers must follow the manufacturer's operating guidelines and position the crane so that it will remain stable throughout the lifting procedure. Another basic preparation for a rigging job is selecting the proper equipment. The capacity of rigging equipment should never be exceeded, and no rigging equipment should ever be used for anything other than its intended purpose. Each piece of equipment that's selected should be carefully inspected. During extended work periods, rigging equipment should be inspected on a regular basis. Once basic preparations have been completed, the rigging equipment can be attached to the load. First, the rigger on the ground attaches slings that he has selected to the crane's hook. Then, he signals the crane operator to position the hook above the load. He then attaches the rigging to the load, making sure that none of the slings or load lines are crossed or kinked. With the equipment in place, the rigger signals the crane operator to slowly raise the hook to take the slack out of the rigging. He does this to make sure that the rigging is secure and that the hoist line is directly above the load's center of gravity, which is necessary to prevent the load from swinging when it's lifted. If the load swings, it could be a danger to personnel in the area, and it could damage the load or other equipment. Next, the rigger signals the crane operator to slowly lift the load a few inches so that he can make sure that the load is properly balanced. If the load isn't balanced, it will have to be lowered so that the rigging can be adjusted. Once he verifies that the load is balanced, the rigger attaches a tag line to help control the load as it's being moved. Then he signals the crane operator to slowly lift the load high enough to clear any obstructions in the area. He continues to direct the crane operator along the route until the load is positioned just above its intended location. There he arranges the supports underneath the load and signals the crane operator to slowly lower the load. Then he disconnects the rigging equipment from the load and removes the equipment from the crane's hook. He completes the rigging job by returning the equipment to its proper storage place. With the equipment in place, the rigger signals the crane operator to slowly raise the hook to take the slack out of the rigging. He does this to make sure that the rigging is secure and that the hoist line is directly above the load's center of gravity, which is necessary to prevent the load from swinging when it's lifted. If the load swings, it could be a danger to personnel in the area and it could damage the load or other equipment.